Hello guys, good afternoon. So today we are going to we are going to take a look at Google Earth Engine. And so what is Google Earth Engine? It's a GIS, but it's a very different type of GIS than ArcGIS Pro or even ArcGIS Online. You can do many of the same things, but it's more, maybe we say, low level in its utilization. It requires some programming to be able to get it to click, to get it to crunch for you. And I also say it's more focused on analyzing raster data. Satellite imagery, including multispectral imagery, and we'll take a look at what that means today. Okay. So we'll learn some new things, which are, just general GIS type knowledge, but demonstrate some of the things that Google Earth can do. Hey, Logan, Alexis, Sean. Hope you guys are all doing well. Sorry, I didn't have any jokes today. All right. Got to open up Chrome. Okay, so the first thing about Google Earth Engine is at this time, who knows what the future holds. I mean, Google is this giant monopoly, and they might decide at some point that they want to charge for this this service. But Google Earth Engine right now is completely free, and that's awesome. Google, it's like, so in line with Google's mission of organizing the world's information. And it's completely free. You just got to sign up and you get an account. And the other thing is you runs in your web browser. You can access the Google Earth Engine resources from a programming script, but the easiest way to get started with it is in your web browser. So that's what we're going to do today. We're going to look at the web browser interface, the Earth Engine console, and we'll do some fun stuff with that. Okay. And that means that it runs in your browser. It doesn't use much of your computer's resources. It crunches stuff out in the cloud using Google's servers. All right. So kind of hard to beat free. So now I just got to get my web browser to work. Here we go. Okay, and I always have trouble finding Google Earth Engine. All right, so search Google Earth Engine. This is different than Google Earth. It's not the same thing as Google Earth. Google Earth is it's a GIS, but it's sort of like a desktop product that runs on your computer, or it's an app that runs on your phone. So Google Earth Engine is more focused on geospatial analysis, being able to perform geospatial analysis, not just mapping. Google Earth is pretty much about mapping, and but we want to analyze data as well. That's what Google Earth Engine is for. So let's start by watching this time lapse. So this is some data that is integrated into Google Earth Engine. So what data is this? This looks like it's satellite imagery. It looks like maybe it's Landsat imagery over the course of 35 years, looking at the retreat of the Columbia Glacier in Alaska. So this time lapse is showing the same region at over different years. Let's find something that coastal expansion in Dubai. We'll go take a look at that. It's crazy. I was just telling my son about Dubai. He said, "Where's the tallest building in the world?" I said, "It's in Dubai." And we were looking at pictures. He's very impressed, but he says, "I think they could build a taller one." I said, "Maybe you will, buddy. Maybe you will." But you can, this time-lapse thing, just zoom. This is the entire Earth. I didn't really make that clear. So let me pause and let's go into West Virginia, see if I can find it. What do we got going on here? You guys see this? This is, Central Appalachia. This is Eastern Kentucky and southern West Virginia. What's going on? You guys see that? This is from 1984. So this must be Landsat imagery through 2019 or 2018. You guys know what this is? What's happening to these mountains? Deforestation or mining? It is mining. Look at this. This is just unbelievable when you watch it happen. Over 20 years. That's right. That's right, Christina. This is mountaintop removal. This is mountaintop removal changing the landscape of the Central Appalachian Mountains. And so this time lapse of satellite imagery of the entire world. I think you can see that projection. Mercator. But you zoom in, it's a record of using satellite imagery of the surface of the Earth over the last 40 years almost, 35 years. And you can see, urban change. If you zoom in, let's see what's been growing a lot lately. I wonder if we can see change along the Gulf Coast. Wow. You just see the erosion of the Mississippi Delta. Crazy. Okay. Anyway, I just wanted to show you that because that's pretty cool. So Google Earth Engine has just integrated with it this incredibly massive catalog of satellite imagery from a whole bunch of different satellite missions. Some from United States NASA, like Landsat, some from the European Union Space Agency, like Sentinel, and these are integrated into the system, and then you can access this imagery with just one line of code. So I'll show you how to do that right now. So let's go to the console. All right, so this is what the console looks like for Earth Engine. Let me see if I can switch over here. Okay, this is what it looks like. And so I'm logged in with my own personal account. You have this place where you can edit code. You have this directory which shows all the code that you've written. So I got a lot of stuff here. We're going to take a look at this one today. All right, and then down here you have a map. And this is just like Google Map. And so one thing you can do on this map is you can draw features, just like you could on in ArcGIS Pro. So if I want to mark the location of Shepherd University, I can put a pin on it, just like this. Pop a pin on it, and you see what happened? It created a geometry, a point geometry, and that point has geographic coordinates. All right. It's minus 77.8. Longitude 39.4. Latitude. All right. And you can also create point geometries using a line of code like this. So there's a function called EE for Earth Engine .geometry.point, and then you feed it coordinates of that point, and it will create a point object. So if I wanted to, so this point is, let me comment out everything that we're not going to use right now. I'm just gonna, so this, if you're wondering, the programming language being used here is JavaScript. All right. You can also program Earth Engine in Python using a Python library that's made for it. So got that in common with I'm just commenting out all these lines so that comments don't get executed when you run the program. All right, I just want to show you that, okay, so now let's see if this works. Oops, got capital M. So I have to find a point by using this geometry, and the coordinates here are right there. So it's right here over near where Tabler Farm is located. So it's just so I could click and create a point feature, and now I could reference it, but I'm going to delete it right there. Okay, and you can also make polygons. You can trace things. You can make polygon features, and it creates a polygon. This one has 5 vertices, and if I open this up, you'll see the coordinates of the vertices. There they are. That defines the polygon, those coordinates. All right, but I'll get rid of that. Okay. So anyway, I'll comment this out. So what I'm doing next here, I'm going to make this a little bigger so you can see this, okay? That's too big. All right, I think you'll be able to see this now. All right. In this next line of code, what I'm going to do is in one line of code, I'm going to import a collection of images, or image collection, which corresponds to Landsat 8. Okay, and so this is, if we go to Earth Engine and look at data sets, you can see all the data sets that are available. They have data sets climate and weather, they have imagery, Landsat, Sentinel, they have high resolution imagery from like the National Agriculture Imagery Program, or NAPE, and they have digital elevation models, they have land cover models, cropland models, what kind of crops where, just so many resources. So I'm pulling in, if you click on Landsat here, you'll see, well, let's see, Landsat 8, the Landsat 8 mission is from 2013 to present, and you can look at this data in different ways. So this is satellite imagery, so it's looking through the atmosphere, and this surface reflectance data is compensating for the losses in the atmosphere. And so we'll click on that, and there's a line of code here that says if you want to use this data in your Earth Engine project, here's the line of data to import it, and that's exactly the line of data that I'm using right here. Well, it's not quite the same. It's tier 1. I must be using oh, it's tier 1 top of atmosphere. That's not the one I want. I want, oops, data sets, not top of, I want surface reflectance. I want surface reflectance. That's tier 1 surface reflectance. Let me copy this and paste it in there. Okay. Paste. Okay. And so now what I'm going to do here in this, so that pulls in all the images in Landsat 8. And then what I'm going to do here is I'm going to, so Landsat images are broken down into these little swatches that kind of just paste over the surface of the Earth. And in about every 2 weeks, the satellite revisits the same point on the Earth. So what I'm going to do here in this next line is I'm filtering out all that images. I'm going to filter only those images that correspond to this point that I've defined here at Tabler Farm. And I'm also going to filter for just the last year, from January of 19 through December of 2019. All right, so that's what that does. And then this line of code pulls out, well, this Landsat imagery has many bands, and so 3 of those bands, B4, B3, and B2, correspond to red, green, and blue colors that we see with our eyes. But then there's also other bands that correspond to infrared, near infrared, far infrared. And I'm just want to visualize these 3 bands of this data, and then I'll pull out one image from this data. And what I'm going to do is pull out the first image. So I'm going to take all the images that are returned after I filter out by date and location, and I'm going to sort them by cloud cover. So I want them, some days there'll be a lot of clouds and some days there aren't, and I just want to take the first image out of that collection, and then I'm going to plot it on my map. Right there. Okay. So I'll save this and run it. What did I do wrong? Maybe there's no images. Here, let me get the inspector and click here. Landsat, oh, it's Landsat True Color. I gotta rescale my images here. Well, let me just change back to top of atmosphere. Then I don't have to worry about the scaling factors too much. There we go. All right, so it's gonna not be really that true to the surface, but so this is for the year of 2019, from January 1st through January 31st. Landsat visited this area a lot. Here, let me make it a little transparent. But of all the images that were taken that included this point, which is actually just down here in the lower corner of this image, this was the image that had the least amount of cloud cover. So on this day, whatever it is, let's click on it. Let's see if we can figure it out. It was a Landsat image. There's 12 bands, so these are all the bands in the image. Some of them are visible bands and some of them are not. And it was taken on September 20th, 2019. Okay, the datum used, WGS 84. A lot of information about this data. So this is an image from the Landsat catalog, one image, and it's raster data, and it's plotted on the surface of the Earth here. All right. So let's keep going here. What I'm going to do next is I'm going to calculate something called normalized difference vegetative index. And let me write out what this is here. and I'm going to add this to the slide deck too, so you know this. This is important to know. This might be the most important metric used in remote sensing. Remote sensing is the practice of using satellites or planes or now drones to gather aerial imagery for analysis. And the way you calculate this, so it turns out that you can estimate the amount of vegetation, leaf, grass cover, material that's undergoing photosynthesis by looking at the difference between the amount of red reflectance and the amount of infrared reflectance. And so the way that this works, let me turn on my camera so I can talk to you. The way this works is that, you know, the reason that the things that have chlorophyll in them appear green is because green is reflected. It's not absorbed by the plant and converted into useful energy to make food for the plant. So photosynthesis uses red light very well, and then the other thing is it reflects infrared. So near infrared is reflected by plants, by things that are green. So what we're going to do is calculate this normalized difference vegetative index. Is we're going to take the difference between the amount of red reflected off the surface and the amount of infrared, and we're going to divide that by the sum of red and infrared. So if you look at, let me just click on a pixel here and show you, like right here, this pixel right here in western Pennsylvania, the red is in the B4, and these values are stretched between 0 and 1. So 0.07 is not a lot of red. That's a pretty green pixel. And then infrared, near infrared, is B5, and that's 0.2. So this is a lot higher. So if you take the difference between these two numbers and divide by the sum, that gives you this quantity called the normalized difference vegetative index. So I'm going to do that now here, and I'm going to do that now and then show you, plot the result using, so this is pulling out the the infrared channel of this image that's plotted down here, and then this pulls out the red, and then this calculates the NDVI. You subtract red from near infrared, and then you divide it by red plus near infrared. And I know this is a little clunky to read, but this is what it's doing. This is just there's a shortcut to doing the same thing. And now I'm going to add that to my map, and we'll take a look at it. Okay. All right, so here what I did was I took this NDVI and I stretched it from color blue through white to green. So green means the NDVI is really high. That means vegetation. White means not a lot of vegetation. So let's try to find a mountaintop removal site. Oh, we won't. Well, I gotta move to southern West Virginia. So let's do that. Why not? I'll pick a point down here, about right there. All right, and now I'm going to filter based on that point instead of the point I specified up here in West Virginia. Okay, so now I'm just at a different area, and let's turn off NDVI and let's try to find a mountaintop removal site. Shouldn't be too hard. This looks like the Hobart mine. And so an area like this should have a low vegetative index because all the vegetation's removed. So let's turn on NDVI. Look at it, it's white. So you can recognize areas that have been mined by the fact that they have a low vegetative index and normalized difference vegetative index. And actually, SkyTruth does stuff like this. SkyTruth, they have an office here in town, and I've done some work with those guys, and they've done this in West Virginia and Eastern Kentucky. They will look at the change in NDVI from one year to the next, or some other metric that they invent, and that helps them figure out how much mining occurred in that period of time. So you can track the expansion of mines, or also the, you know, when mines are finished, they're supposed to re-vegetate, reclaim the mine land, and you can track to see if that's happening as well. All right, and then blue would be like a negative NDVI. So water has a negative NDVI. So that's why I picked the color blue. So if we zoom in here on this river, you see it's blue. Okay, so this one measure, NDVI, tells you a lot about vegetative cover. And so now let's do one more thing before we. When you're working with Earth Engine, you have access to all of these images, these Landsat images or Sentinel images, for going back to, in some cases, 1984, and so in it you can study land change or land use change over a long period of time. What I want to do now, though, is let's just, the NDVI calculates a number which corresponds to vegetative cover, and you can imagine that that number's going to be higher during the summer months. That's when the trees have leaves on, the grass is green. There's going to be a higher NDVI, and then in the winter months there's going to be a lower NDVI when all the trees lose their leaves and grass sort of goes dormant. Now, another factor here is that, when the satellite passes over a given location, if it's cloudy there at that day, then you don't see the ground. So cloud cover has a low NDVI, and if we want to look at a region on the surface of the Earth. And one thing we can do in Google Earth Engine really easily is we can create what's called a mosaic. And we talked about mosaics. In ArcGIS Pro, you can weave two raster layers together to make a mosaic of those two rasters. So you can do the same thing in Google Earth Engine, but this is like that process on steroids, because now what you have is this catalog of, maybe for a given point on the surface, a couple hundred images of that have that point in them over the course of a time period. And what it will do is it'll look at every pixel and it will find the greenest pixel. And what I mean by greenest, the one that has the highest NDVI. And it uses that pixel to create a mosaic of the entire region. All right, so let's do that. All right. So we created the NDVI, we plotted it. In order to do this, though, we've got to apply this NDVI to not just the one image that we pulled out, but all of the images in the entire image collection. All of these, we created this image collection of all this Landsat imagery, and we want to add it to everything. So we're going to create a function that adds NDVI to the image, and it's going to apply it to every image that's in this image collection, L8 filtered. All right, and then this function here called quality mosaic is going to look at this channel that we created, NDVI, and it's going to pull out the pixel that has the highest value of NDVI for every pixel in every image that we have and mosaic them all together. And then we'll add it to the map. All right, and so all the layers are here. We'll turn off the NDVI and Landsat. So this is the greenest pixel composite for this region. And let's move back up here to didn't want to do that. Coming up to Martinsburg. I'm going to change this back to this point at the farm. Okay, so here you can really see that there's a bunch of images weaved together. Oops. You know, right here I can see that. So this is something that you've experienced when you zoom in on maps all the time. There appears to be this boundary between two images here. So these are from different passes of this satellite, and so what this means is that there's spatial alignment here, but not temporal alignment. That this data is from a different point in time. Let's see if we can figure it out. If I click here, let's see. I was hoping I could drill down and figure out. Well, I know we can. You can figure out the date that each pixel was taken. But there's definitely a barrier there. So you have two different passes of the Landsat satellite, and both of them include the region that's in Tabler Farm. And just for your knowledge, Landsat, if you zoom in here, you can see the individual pixels of the Landsat image, and you can see that some of them are kind of stretched and weird. That's because this is a two-dimensional picture that's projected onto the three-dimensional surface of the Earth, which is then projected back onto a two-dimensional surface. So you have projections going on here, and that means that these pixels are not perfectly aligned, and there's a little bit of fuzziness at the edges. But each of these pixels is approximately, the resolution of the Landsat mission is 30 meters. So you have approximately 30-meter resolution on the surface of the ground. Okay. Let's take a look at, well, maybe we save that for another, we got some time. So let's take a look at, there's some high, I'll just open up one of my projects where I use this. So there's other, besides the Landsat imagery, there's a whole bunch of other catalogs of imagery that you can use in Google Earth Engine. And then you can apply functions to this imagery just like you could in ArcGIS. Remember, we used the mask functionality to take raster data and use a polygon, which was the outline of the vineyard property, and we cut out just the inside of that vineyard property and just kept that data. So you can do the same thing here in ArcGIS or in Earth Engine. Let's take a look at something like that. Okay. Let me see. Here, we'll take a look at Levittown. So Levittown in New York. I did this last year because I was fascinated by Levittown. Let's run this. All right. So do a newer version. So I created this map which pulled out some satellite imagery of Levittown, which is this polygon here, and then it cropped it to the edges. What's the function? There, created a there it is, clip. So there's a function called clip, which clipped the imagery to this bounding box, which is defined by the border of this zip code, which is approximately Levittown, New York. So Levittown, and then I added a bunch of text in here. So this map is shared with the public. You could read all about Levittown if you want. It's a fascinating thing. And you know, you can have layers, you can turn them off and on, you can control transparency. You can do a lot of stuff with these maps. And you can share them freely on the internet. So you can create online maps just like you could in ArcGIS Online. But it's sort of a more low-level approach involving programming. But this is like really high resolution data. Look at this. Zoom in. This is like 1 meter resolution. You can see individual houses. And so this data is taken from NAPE, the National Agriculture Imagery Program, U.S. Department of Agricultural Food Service Agency. And so I have another one that's, let's see, Fort Bridger. Let's take a look at, nope. So this is out in Wyoming. Oh, shoot. Oh, that's the Lincoln Highway. I was doing a project mapping the Lincoln Highway. Hold on. Try this one. It's part. So I was tracing the Lincoln Highway. Hold on. Let me find it. Yeah, where is it? Midwest Parcels. There we go. Midwest Parcels. Let's take a look at this. So I got this out here in Colorado, northeastern Colorado. Let's run this and then zoom in. So I defined a bounding box between these 2 points, and then I cropped out a piece of the NAPE imagery using this clip function. And zoom in here, and what do you see? Let me make this bigger. I was fascinated by this. It's pretty beautiful. What am I looking at here? Anybody know? It's like some sort of alien crop circles. There's a whole bunch more up here. So this is I don't know what river that is. What river is that? South Platte River. It goes through here. So you got a little river flowing through here. What are these things? So it's pretty high. It's pretty high resolution. Zoom in. So again, this is that NAPE imagery. It has meter resolution. So each of these pixels is 1 meter by 1 meter on the ground. Pretty impressive. You guys know what those are? What's going on there? Why is there circles? Why are these crops being grown in circles? Anybody know? This is what's destroying the water resources in the West. Irrigation circles, that's right. So this is center pivot irrigation. So you got, zoom in here, you can even see the irrigation apparatus. So you got a well or a well-fed system that's sitting here in the middle, and then you got this long irrigation apparatus which is on wheels, and you can see the wheel tracks, and it'll pivot about the center and go around in a circle and irrigate the crops in this circle. Center pivot irrigation. And then you got a field here with a much larger diameter. But this is pretty widespread out west. You fly over this country and you see this everywhere. And you'll see it in Arizona. You'll see it in places where you're like, wow, they have surface here. They have large-scale agriculture here, and a lot of it is sustained by groundwater. That's people call it mining for water, because if you think, well, what makes something mining versus just utilizing water resource? Water resources we think is being replenished, but these deep aquifers that are being tapped is a water resource that's been in place for tens of thousands of years, and or at least thousands of years. So it will take about that long for that water to be replenished. So we're depleting these aquifers much quicker than they're refilling. So it is a non-renewable resource. It's being utilized at a rate that's much faster than its natural rate of replenishment. So it's non-renewable, and but a lot of agriculture is based on this. So anyway, I hope you like some of this. So some of these topics you will be tested on. NDVI, what is a normalized difference vegetative index, and what is it good for? But I'm not testing you on Earth Engine specific knowledge. It's not the focus of this course, but it is a really cool tool, and it's free to utilize, and there's tons of resources out there. And it's when it comes to using satellite imagery, it's really hard to top in terms of the power that's at your fingertips to just access this. Google has cataloged, I don't know, petabytes of data in satellite imagery, and it's just available at your fingertips. You can pull it up in one line of code. All right. So, all right. I'll see you guys on Monday. That's it for today. And will you add that information to the Google slide presentation? I will, Alexis. It will be added, and I have some updating to do. I've been adding some stuff along the way, but I'll be adding a lot more in the next week or so. All right. I will talk to you guys on Monday. Have a great weekend. Bye.